So we're working backwards. We're starting here, and we're working backwards. Set them equal to 0. Add 3. Good. Subtract 4. Okay. Now, just get them out of the 0, bring them back to a factor. And you can leave them like this. Or, in this case, if you FOILed it, or distributed, whatever, minus 4x plus 3x, you get your quadratic. Now, the nice part about when we do this is we can leave them in factored form. We don't have to FOIL anything out because it usually will have more than just 2 roots. But this is basically how you start this. You just work a backwards approach. So if you forget what to do, take a simple quadratic and work it forward. And you follow those steps to go backwards. Okay? Now, if I have a trinomial, you guys okay with this? If I have a trinomial of a cubing function, say I have a cubing function, and I'm passing through, I pass through here, I pass through here, I pass through here. I want to know what is my equation of this function. Same way, I work backwards. I start with my solutions, and bring them back to where we set them equal to 0. We had 3 this time. So what should my highest exponent be when I'm done? 3. God bless you. So set them back equal to 0. And bring them out as factors. So here is your factored form. There's your equation in factored form. Now, if we wanted to find the x cubed thing, we would just FOIL this together and then distribute it over the last one. But you can leave them in factored form. I'm absolutely fine with that. Okay? So no matter how many we have, it's the same approach. Start with your roots, set them equal to 0, bring them out into the parentheses, and I will say this. This is one of the biggest mistakes. Not doing this step, not setting it equal to 0. This is not x minus 5. This is x plus 5. It's the opposite. So you'll have to bring it back to the opposite. Now, we have another condition, and we have one more condition that happens to say, I have a parabola, and it has imaginary roots. I have imaginary roots. So let's say my roots are 3 plus or minus 2i. Let's say those are my imaginary roots. I don't even know if it's going to look like this parabola, but let's just say those are my imaginary roots. That means I have a parabola. I still have the x squared, ax squared plus bx plus c. I still have the same thing, but it doesn't touch the x-axis. But I have to bring these back the same way. These are conjugates. So even if I gave you one of them, you would know that the other one just has the opposite sign in it. They're conjugates. Now here's a problem. You have to set these equal to 0. You can't just take those 2 little things and make them be your factors. It doesn't work that way. So you have to set this equal to 0. You have to set them equal to 0. And then you have to FOIL that little mess. So instead of doing that, we have 2 little formulas that help us. And I don't know if you remember these. The sum of the roots is equal to negative b over a. and the product of the roots is equal to c over a. From there, we can plug it into your quadratic. Do you remember these from Algebra 2? Those were those two little formulas that were really helpful, that are hard to remember, but they're really helpful. Now, what's nice about your 2i, or even with a radical, even with a, like a radical 3 or a radical 2, you never see your quadratic with a radical in it. So when you multiply them, I times I squared, that's -1. It's gone. Radical times radical, radical 3 times radical 3, it's 3. It's gone. So it works out very nicely. And because they're conjugates, when you add them together, you'll get rid of the I or the radical. So these work really, really nicely when you're kind of stuck and you don't want to have to do it the long way. So let's do the sum of our roots. So we're going to take these two factors. Now write these down, guys. Here's your sum. 3 plus 2i, 3 minus 2i. You can even do this on your calculator. What happens to the 2i's? Cancel. So your sum is equal to 6. This is important. Your formula is equal to -b over a. So let's put this over 1. So to start this, because we have two variables and we can only solve for one, we say let a equal 1. When a is equal to 1, then this 6 is equal to -b. So what's b equal to? -6. So therefore b is -6. Okay? Okay with that? Okay, product. Product is even easier. Your first term, your first root, 3 plus 2i. Your second root, 3 minus 2i. These are perfect squares. You can, number one, put them in your calculator, and the I for your imaginary is right above your decimal point. Or you can use your perfect squares. Multiply your first terms, multiply your last terms. What's 3 times 3? A positive times a negative gives me a negative. And what's 2i times 2i? 4i squared. And what is I squared? -1. So a negative of a negative is positive. Therefore, the product is 13. Product is equal to C over A. Well, we let A equal 1, so therefore what does C equal? 13. So now I have all the pieces to make my quadratic. So f of x is equal to 1x squared minus 6x plus 13. That will give you a quadratic that has those roots. Sum and product. And you can do the sum and the product right on your calculator. Whether it's an I or a radical, this works for both. Instead of putting an I in here, if I put a radical 3, those would cancel out, right? If I put a radical 3 in here, a radical 3 times a radical 3, 3. It's gone. But do it in your calc. That part you can even do in your calc. Just watch your parentheses. Good? So, let's head to our original problem. I'm given these zeros, and I need to find the function that has these zeros. First of all, how many zeros do I have? 4. I have 4 zeros. So my highest exponent should be 4. Okay? Now, what are these called? They're not imaginaries. They're irrationals. They work like the I. These are called conjugate pairs. These come from your quadratic equation. You know, when you get to the bottom of your quadratic, -b plus or minus that whole thing, There's your 4 plus or minus radical 5. Those are your conjugate pairs. We're going to work these the same as we work the I. The I is the square root of -1. So any radicals and any i's, we work those together. So we start like this. X is equal to 0. X is equal to 2. And this guy we're going to group together. So the first thing we're going to do is come up with a quadratic that has those 2 roots in it. You've got to work 1 root at a time. So let's do our sum. Sum is negative b over a. What's the sum of these 2 roots? If you added them together, what's your sum? 8. Don't the radicals disappear? They work just like the i's. 4 plus radical 5. 4 minus radical 5. 8. And you can do that on your calculator. So we're going to let a equal 1. And so therefore, what does b equal to? Negative 8. B has to be positive when you give me the answer. So you're going to have to switch the sign there. Okay, now we're going to do the product. Product says 4 plus radical 5 times 4 minus radical 5. You can do that in your calculator, or you can do the perfect squares, because the middle terms are going to cancel out. So what's 4 times 4? And what's radical 5 times radical 5? Negative 5. Good. The negative from the positive times the negative, and when you multiply a radical times itself, it just comes out of radical. What's 16 minus 5? So your product is c over a. If a is 1, what is c? 11. So this part, we know. X squared minus 8x plus 11. Oh, it's very, very familiar. That's an x squared. Okay. Now, all we have to do is get these factors. So set these equal to 0. So x minus 0, I really don't need x minus 0, but we'll set it equal to 0 anyway. So that's your x factor. X minus 2, so there's your other factor. And here's your third factor. Remember to put it equal to something, equal to f of x, equal to y. It's got to be an equation. Now, if I wanted to, I could distribute this out, and then I could distribute it with this. You don't have to. You can leave them in factored form. You can put this in your y1, and you can look for your roots. Now, the thing is, when you pull this up and you look for your roots, the easiest way is do it with the calc valve. Put in x is 0, see that y is 0. Put in x is 2, see that y is 2. Put this in your x equals 4 plus radical 5. Like that. Don't round it. And you will see y is 0. If you round it, or you have to put it in your calc, it's never going to come out to be 0. It will be close because you round it. But that is the exact root when y is 0. So do I have x to the 4th? X times x is x squared times x squared is x to the 4th? Yeah? Do you want to try another one? Yeah, you do. Kyle says, yeah, he does. Okay. He was lying, I know. Okay, so find me a quadratic whose zeros are It's a little tricky. How many, what's the highest exponent going to be? The double. Nope. 6. Who said 6? 6? Why'd you say 6? Okay. Because this guy came from your quadratic equation, so it needs its conjugate, 2 plus radical 3. So there's your 6th root. This is a double. A double root will give me what? X squared, right? And this you'll have to do, you can't have one of those without the other conjugate. They come from your quadratic. When you do your quadratic, when you get down to the end, you always get 2 plus or minus radical 3. 2 minus radical 3, 2 plus radical 3. So your conjugate pairs, they have to be a pair if you use your quadratic. You always get that plus or minus. Or if you complete the square, you take the square root, you get the plus and minus. So see if you can come up with the equation for this function. I threw a lot in there. All right. So you just have that is